All right, number 41, if we have two similar triangles, that means the sides are in proportion and also means that the corresponding angles are congruent. So if we're supposed to find the measure of angle V here, that should be the same as the measure of angle S here. So we know the inside angles of a triangle, those are going to add up to 180. So I'm going to just take, and you guys will see this on the screen, 180, and we will subtract the 38-degree angle and the 59-degree angle, and the leftover has to be angle S, also has to be angle V. So that's going to be 83. For 42, we're going to find the midpoint of AB given that the endpoints are 2, 9 and negative 10, 7. If you guys remember the midpoint formula, midpoint here, you're going to take the two x coordinates, which are 2 and negative 10. You're going to add them together and divide by 2. It's taken an average. To get the y coordinate of the midpoint, you're going to take your two y coordinates, 9 and 7 of the endpoints, add them together, divide by 2. Right here, we would end up with negative 8 over 2. Right here, we would end up with 16 over 2. And then, of course, if we can simplify, we'd want to. So our actual answer here should be negative 4 and positive 8. We're going to find missing values in the triangle for number 43. So first one I'm going to do, let me find x first. I can see that there's a triangle here. It's 50, 59, and x. So let me come up to my lovely calculator. I know every triangle adds up to 180. So we're going to subtract 59, subtract 50, left over 71. That's going to be your x. Now here, x and y, those two angles form a straight line, so those are supplementary, so I know those have to add up to 180. So if I do 180 minus 71, that's going to make angle y 109. And then if I kind of cover up this triangle for a second, you got a triangle here, 29, 109, and z have to add up to 180, because any triangle I've got there's got to do that, so I'm going to do 180, subtract the 29-degree angle, subtract angle y, which is 109, and that makes z 42. Let's slide up to number 44 here. Isosceles triangle has a vertex angle 28. So let me just, not to scale or anything, but we'll sketch a picture. The vertex angle in an isosceles triangle is the angle that is not the same as the two base angles. But we do know if we have an isosceles triangle, we have two sides the same, and the angles opposite those two sides will be the same. So we want to know the measure of one of the base angles. Okay. So let me do 180 minus 28, and you guys will see that on my calculator here. And we've got 152. Now, I know these two angles, they have to be the same. They just want one of them. So I have to divide that 152 evenly between those two angles. So we're going to divide that by 2. So one of the base angles would be 76. That's going to be your answer there. For 45, geometric mean means you take the two numbers, multiply them together, and take the square root. So we're going to get 12. Now, this says we want to write our answer in simplest radical form. So factor tree, or if you prefer, use the biggest perfect square that'll divide into 12. That's what I'm going to do. Biggest perfect square that'll divide into 12 is 4. Square root of 4 is 2, so I can take that out from under the radical. 3 stays under the square root. So in simplest radical form, geometric mean, you take the two values they give you, multiply them, and take the square root. If it's not a perfect square like it was here, we want to break it down into simplest radical form. All right, 46, the converse of a conditional switches the hypothesis and the conclusion. So we're going to take the then part and put it at the beginning. I'm going to say if its coordinates are positive, then the point is in the first quadrant. Converse just switches the hypothesis and the conclusion of a statement. All right, for 47 here, there's a couple of things going on in this picture. This is an angle bisector, and because this is an isosceles triangle, if you have an angle bisector of the vertex angle, that tells me that it's the perpendicular bisector of the base. And because I've got these isosceles sides marked being the same here, the two base angles are going to be the same. So that's going to help me complete this problem. Now, y right there, because of that bisector theorem, is going to be a right angle or 90 degrees. This angle will be 52, and so we know the inside angles of a triangle add up to 180. Oops, let me scooch my calculator over here. So clear this out. I've got 180, we've got a right angle, and we've got a 52 degree angle, so we're going to subtract both of those, and that's going to make x 38. All right, scale drawing. This one throws people off because you kind of have to do two problems in one. So the bedroom your living room in real life is 15 feet by 24 feet. We want to know what it's going to be on the model. You don't have to do any conversions or anything here. We're just going to use the scale they give us. 2 inches is 3 feet. Now, because this is the scale, we don't have to do a conversion like I said. I'm going to take the 15-foot side of the bedroom and put it here, and I'll just call that X. And we literally are just going to set up the exact same proportion for the other side of the living room, put the 24 feet. I'm matching up the units that are the same. These are both the real-world measurements, and then we're finding the missing measurement for the scale drawing. Then, this is just cross multiply, divide. 2 times 15 is 30. If we divide that by 3, that's going to leave us with a 10-inch on the scale model here. And 2 times 24 is 48. If you divide that by 3, y is going to end up being 16 inches in the scale drawing.